Hi everyone, my name is Mark Littlefield. I'm Director of System Products at Elmo Electronics. And I and my colleagues are excited for the opportunity to introduce you to QMC, the new small form factor I/O mezzanine standard that we've been working on. We had hoped to have it actually done and in the can by today. It's not quite there. We have probably one more ballot round to clean up a few little things, but we're about this close to having it go out to ANSI. And so this is a good time for it to be introduced to the community. I'm going to introduce what it is, how it came to be, what its benefits are, and so on. My colleagues from Acromag and TEVS will be talking a little bit more about the actual technology that's going into the standard. So what is QMC? As I said, small form factor I/O mezzanine. Same kind of concept, and you'll hear this over and over again, same kind of concept as XMC, but in a much smaller package. It was designed, oh, and I should be showing my show and tell here. So this is QMC, okay? It's really small form factor. It's designed to be modular and that you can have multiples of these in a system. It's designed to be scalable so that you can actually have double wide, triple wide, or quad wide versions of this. It's designed from the beginning to be rugged for military grade applications, but there's both an air cooled and a conduction cooled version as part of the standard. It's basically, I mean, it's really designed as an I/O mezzanine. So it has two connectors. It has the high-speed host side connector and also a high-speed I/O side or user connector. And that user I/O can either be directed to the front panel of a system or to the backplane. In addition, we chose a connector that has, it's very high-speed, high-performance connector. So we expect this as a standard to have legs. It's going to be around for a few years. So what is the inspiration for QMC? And I'm going to put this down because I don't want to be dropping things. The inspiration for QMC actually came out of VNX Plus. VNX Plus, or VITA 90, is a small form factor module. You see, quite small, but it's got a lot of the same capabilities as, say, an OpenVPX module might have. You know, a very high-speed connector, data plane, control plane, expansion plane, blah, blah, blah. What we needed was an I/O expansion capability. And this module is too small for XMC, which is the typical go-to for mezzanine I/O expansion in OpenVPX. So what we did is in July of 2022, we started a study group in VITA, looking at the problem, gathering our requirements, doing our trade studies, trying to find a suitable small form factor mezzanine that we could use in VNX Plus. There are some out there. There's M.2 that's pretty well established, Mini PCI Express, the AcroPax, and a few others. But none of them really ticked all of the boxes. And so what we said is, let's start a new standard. Let's see what we can do that will tick all of the boxes that we want to tick. And so we finished our report in early 2023, kicked off a working group in March, and then since March, we've been diligently trying to put this standard together. We had several objectives we wanted with this standard. Again, a mezzanine I/O that was small enough to fit inside that 19 millimeter VNX Plus module. The host side connector needed to be, we needed both a host side connector and an I/O side connector, much like XMC is. We wanted high performance, at least PCI Express Gen 5. We wanted both air-cooled and conduction-cooled versions, and we wanted to be able to support military-grade rugged, so it had to stand up to the shock and vibration of those mil-grade applications. Secondary, but still pretty important, and this came out of the study, was that we wanted to be able to support other form factors. You know, VNX Plus was kind of the driver, but we said, you know, why limit to VNX Plus? So we said we wanted to be able to support at least VPX, VME, Compact PCI and PCI Express, and PCI Express Edge fingers. Now, surprisingly, those various form factors caused us a fair amount of work in making sure that what we came up with actually made sense for all of those form factors. And but I think it was worth the work, because what it's doing is it's going to enable a wider community of users for QMC. So what role is QMC going to play in the market? As I said, it's basically doing the same thing that XMC does today. It's all about expansion. Adding I/O ports to a board or to a system, adding like additional computation, like FPGAs, GPUs, and in addition, like there's new AI ASICs available, and then storage. The thing is, it's just a much smaller package. This is a great illustration, and I think it was the Acromag folks that put this together to give you a sense of the scale of this package. And so, like I said, because we designed it from the beginning for rugged deployed applications, it's particularly well suited for that. So I'm going to wrap up by taking a look forward at what's coming up next. Now, we'll be talking a little bit about it in the presentation, but we do have a couple of DOT standards we're working on, some additional things to add to the infrastructure. But the core QMC is in the .0 standard. From here, what we want to make sure is that we've got good coverage in the other carrier standards. Things like VNX Plus, it's already captured in VITA 100. It's already nominally captured in. VITA 100 is still naturally in work, but it's already accounted for in VITA 100. We want to work with Greg and see if we can't get it into OpenVPX so that there's language to direct how to use that back panel I/O. And then we'll be talking with the PICMIG folks about how we can maybe incorporate it there as well. Interoperability between modules and carriers between different suppliers, naturally a concern for new standard, not so much for this. We have done an incredible amount of work to ensure this. One thing I didn't mention is that because there's air-cooled and conduction-cooled versions, you can actually intermate an air-cooled QMC with a conduction-cooled carrier and vice versa. We ensured that. One rule we had going forward from the beginning, any QMC, any carrier. It's rugged by design, so it's good for lab, it's good for factory work, it's good for field deployment. However, because of its nature, because of its size and shape and what have you, it's small. Designers are going to have challenges in cooling this. There's going to be swap challenges that people are going to have to work a little bit to be able to meet, especially when you're learning the new technology, figuring out how best to use it. I think that people are going to be very innovative about cooling. I think that we're going to see some kind of interesting carrier designs, and we might start off in the low single digits, or maybe in the single digits, or maybe low double digits in power consumption per slot. But I think we may see that go up over time as cooling designs take effect. But what's really exciting is that it's a high enough performance mezzanine that we'll start seeing applications in things like autonomous vehicles or edge computing or artificial intelligence.